What if I told you that there are signals coming from deep space that repeat every 16 days with clockwork precision, and we have absolutely no idea what's causing them? What if I told you that entire galaxies are rotating in ways that violate the fundamental laws of physics? And what if I told you that something invisible is literally pulling our universe apart faster than the speed of light, and we've named it after our own ignorance? You think we understand the cosmos? Think again. Despite decades of advanced technology, billion-dollar telescopes, and the brightest minds in science, there are cosmic mysteries so profound they're making astronomers question everything they thought they knew about reality itself. Welcome to Space Prime. I'm your host, and today we're diving into the cosmic enigmas that have been driving scientists to the brink of madness for decades. These aren't just unsolved puzzles. These are phenomena so bizarre, they might be revealing that our entire understanding of the universe is fundamentally wrong. Prepare to question everything you thought you knew about space. The wow signal's cosmic cousin. Let's start with something that's been keeping radio astronomers awake at night. Fast radio bursts, or FRBs. But I'm not talking about your average mysterious space signal. I'm talking about FRB 180916.0158+65, a signal so strange it's rewriting the rules of what we thought was possible in the universe. This isn't just any fast radio burst. Most FRBs are one-time events. They flash once and disappear forever, like cosmic camera flashes going off in the darkness. But FRB 180916 is different. It repeats with mathematical precision every 16.35 days, like clockwork, for exactly 4 days, then goes silent for 12 days, then starts up again. Think about what that means. Something out there, 500 million light-years away, is following a schedule more precise than most human activities. It's like receiving a cosmic alarm clock that's been going off at the same time for years, and we have no idea who set it or why. The signal releases more energy in a few milliseconds than our sun produces in 3 days. We're talking about bursts of radio waves so powerful they can be detected across half the observable universe, yet they last less time than it takes you to blink. Scientists have proposed dozens of theories. Maybe it's a neutron star with a companion object that blocks the signal periodically. Maybe it's some exotic cosmic phenomenon we've never seen before. Maybe it's evidence of technology so advanced it operates on timescales we can barely comprehend. But here's what keeps me up at night: the precision. Natural phenomena in space tend to be chaotic, irregular, random. Pulsars spin regularly, but they slow down over time. Orbital periods shift due to gravitational influences. Almost nothing in nature maintains perfect timing over astronomical distances and timescales. Yet this signal has been repeating with mechanical precision for years, and it's not alone. We've now detected several other repeating FRBs with their own mysterious patterns. It's like someone is playing a cosmic symphony of radio signals, and we can't figure out who's conducting the orchestra. The galaxy that broke physics. Now let's talk about something that's making physicists seriously consider whether our understanding of gravity is completely wrong: the rotation curves of spiral galaxies. Here's what should happen according to everything we know about physics. Stars on the outer edges of a galaxy should orbit slower than stars near the center, just like planets in our solar system. Mercury races around the sun much faster than Neptune because it's closer to the gravitational source. This is basic Newtonian mechanics that's been proven countless times, but spiral galaxies didn't get the memo. When astronomers measured the rotation speeds of stars in spiral galaxies, they found something impossible. Stars on the outer edges were moving just as fast as stars near the center, sometimes faster. According to our understanding of gravity, these outer stars should be flying off into space. The visible matter in these galaxies simply doesn't have enough gravitational pull to keep them in orbit. So, scientists did what scientists do when faced with impossible observations. They invented an explanation: dark matter, an invisible form of matter that makes up 85% of all matter in the universe, but interacts with nothing except gravity. It's everywhere, surrounding every galaxy, yet we can't detect it directly despite decades of searching and billions of dollars in research. But here's where it gets really weird. Some galaxies, like NGC 1052-DF2, appear to have almost no dark matter at all. If dark matter is supposed to be everywhere, holding galaxies together, how can this galaxy exist without it? It's like finding a building with no foundation that somehow doesn't collapse. Other galaxies, like Dragonfly 44, appear to be made of 99% dark matter with almost no visible stars at all. We're looking at invisible galaxies that we can only detect through their gravitational effects on light from more distant objects. Either we're dealing with a form of matter that makes up most of the universe but remains completely mysterious, or our understanding of gravity, one of the four fundamental forces, is so wrong that we need to rebuild physics from the ground up. The universe's impossible expansion. Speaking of rebuilding physics from the ground up, let's discuss the discovery that won the Nobel Prize, while simultaneously shattering our understanding of reality: the accelerating expansion of the universe. For decades after Edwin Hubble discovered that the universe was expanding, astronomers assumed that expansion would gradually slow down due to gravity. It made perfect sense. All the matter in the universe should be gravitationally attracted to all the other matter, gradually putting the brakes on expansion. In 1998, two independent teams of astronomers set out to measure exactly how fast the expansion was slowing down. What they found instead was so shocking that they spent months checking and rechecking their data, convinced they had made a mistake. The expansion of the universe wasn't slowing down, it was speeding up. Something was pushing the fabric of space-time apart faster and faster, overcoming the gravitational pull of all the matter and energy in the observable universe. This force was so powerful that it made up about 68% of everything that exists, yet we had never detected it, never predicted it, never even imagined it was possible. We call it dark energy, which is essentially a confession of ignorance. We have no idea what it is, how it works, or why it exists. We just know that something invisible is literally tearing the universe apart, and it's getting stronger with time. Here's the truly terrifying part. If dark energy continues to accelerate, the ultimate fate of our universe is the Big Rip. A scenario where the expansion of space becomes so rapid that it overcomes every other force in nature. Galaxies will be pulled apart, then solar systems, then planets, then atoms themselves, until nothing remains but isolated particles drifting through an empty cosmos. We're living in a universe dominated by two invisible phenomena, dark matter and dark energy, that we don't understand, can't directly detect, and that together make up 95% of everything that exists. We literally don't know what 95% of our universe is made of. The Tabby's Star Mystery. Now let's talk about KIC 8462852. Better known as Tabby's star, an object so bizarre that it briefly made astronomers seriously consider whether we were looking at evidence of alien megastructures. Most stars dim in predictable patterns when planets pass in front of them. A planet like Jupiter might block 1% of a star's light. Even the largest known planets rarely block more than 2% of their host star's brightness. Tabby's star dims by up to 22% in completely irregular patterns. Sometimes it stays dim for days, sometimes for months. Sometimes it flickers rapidly like a broken light bulb. Sometimes it gradually brightens and dims over weeks in ways that follow no pattern astronomers have ever seen. The dimming events are massive, chaotic, and apparently random. Whatever is blocking this star's light is enormous, larger than Jupiter, and it's not following any predictable orbit. It's not a planet, it's not a comet, it's not a dust cloud, and it's not any natural phenomenon in our catalog of cosmic objects. When astronomer Tabitha Boyajian first published her findings, the scientific community was baffled. Some researchers half-jokingly suggested that we might be looking at alien megastructures, massive constructions built by an advanced civilization to harvest their star's energy. The idea sounds like science fiction, but the observations were so strange that even serious scientists had to consider it. After all, if you were an advanced civilization that needed enormous amounts of energy, building massive structures around your star would be a logical step. But years of follow-up observations have only deepened the mystery. The star's brightness changes aren't just irregular, they're accompanied by color changes that suggest whatever is blocking the light is partially transparent and has complex internal structure. Recent theories involve massive clouds of dust created by colliding asteroids or swarms of comets in highly eccentric orbits. But none of these explanations fully account for all the observed phenomena. phenomena. Tabby's star remains a cosmic enigma that's teaching us our catalog of possible cosmic phenomena is woefully incomplete. The impossible void. Let me tell you about something that shouldn't exist according to our models of how the universe formed. The Buddha's supervoid, also known as the Great Nothing. This isn't just empty space. Space is mostly empty anyway. This is a region of the universe that's so empty it contains almost no galaxies at all across a volume 330 million light-years in diameter. To put that in perspective, if our local group of galaxies existed in the Buddha's supervoid, the nearest other galaxy would be so far away that we wouldn't know other galaxies existed until we invented radio telescopes. Here's why this is impossible. Computer simulations of the early universe, based on our understanding of dark matter and cosmic evolution, predict that matter should be distributed in a cosmic web of filaments and clusters. Empty regions should be no larger than about 120 million light-years across. The Buddha's supervoid is nearly 3 times that size. It's like finding a hole in the cosmic web that's so large it couldn't have formed through any known process. But it gets stranger. The few galaxies that do exist in the void are moving in ways that don't make sense. Some appear to be fleeing the center of the void, as if something is pushing them away. Others show signs of unusual evolution, as if the extreme emptiness has affected their development in ways we don't understand. Some cosmologists have proposed that the void is evidence of exotic physics from the earliest moments of the universe, perhaps the scar left by colliding bubble universes in a multiverse, or the result of some form of matter or energy that we haven't discovered yet. Others suggest it might be connected to the mysterious force we call dark energy. Maybe the void is a region where dark energy is particularly strong, pushing matter away more aggressively than elsewhere in the universe. The truth is, we have no idea how something this empty could exist, and its very presence is calling into question our models of cosmic evolution, the alien mineral that fell from space. Finally, let's discuss something that literally fell into our hands, but has been puzzling scientists for decades: the Allende meteorite and its impossible mineral compositions. When this meteorite fell in Mexico in 1969, scientists expected to find the usual mix of cosmic materials: iron, nickel, silicates, maybe some rare elements. What they found instead were minerals that shouldn't exist anywhere in the universe. The Allende meteorite contains calcium aluminum-rich inclusions, or CAIS, that formed under conditions so extreme they require temperatures over 2,000 degrees Kelvin and chemical environments unlike anything we see in our solar system today. These inclusions are older than Earth, older than the planets, possibly among the first solid materials to condense in the early solar nebula. But here's the impossible part. Some of these minerals show isotopic ratios that don't match anything else we found in our solar system. The proportions of different atomic variants suggest they formed in environments with completely different nuclear processes than what we see around our sun. Some researchers believe these anomalous materials originated outside our solar system entirely, literal pieces of alien worlds that somehow got incorporated into the asteroid belt. Others think they're evidence of exotic nuclear processes that occurred during the formation of our solar system, but have since ceased. Recent analysis has revealed even stranger compounds, minerals with structures that require pressures and temperatures that shouldn't have existed during the peaceful formation of asteroids. It's as if pieces of this meteorite experienced violent, high-energy events that we can't explain with our current understanding of early solar system evolution. The Allende meteorite is teaching us that the early solar system was far more chaotic, far more violent, and far more complex than our models predict. And it's raising uncomfortable questions about whether some of the materials in our solar system might actually be visitors from very far away. So, there you have it, just a small sample of the cosmic mysteries that are keeping astronomers awake at night and forcing scientists to question fundamental assumptions about reality. Signals that repeat with impossible precision, galaxies that violate the laws of physics, a universe torn apart by invisible forces, stars that dim in ways we can't explain, voids that shouldn't exist, and alien minerals falling from the sky. These aren't just unsolved puzzles waiting for better technology or more data. These are observations that are actively challenging our most basic understanding of how the universe works. They're suggesting that either our physics is incomplete or the cosmos is far stranger than we ever imagined. And here's the truly humbling part. For every mystery we've discussed today, there are dozens more waiting to be discovered. Every new telescope, every advanced detector, every deep space survey reveals phenomena that don't fit our theories. We're living in a universe that's constantly surprising us, constantly reminding us how much we don't know. And that's exactly what makes cosmic exploration so exciting. Which of these cosmic anomalies fascinates you the most? Do you think we're missing something fundamental about how the universe works? Let me know in the comments below. And if you want to stay updated on the latest cosmic mysteries and scientific discoveries that challenge everything we think we know, subscribe to Space Prime and hit that notification bell, because in a universe this strange, you never know what impossible thing we'll discover next. Thanks for watching Space Prime. Until next time, keep questioning the impossible.